Okay, so we're on page 2 of our review. Let's start with number 10. So again, we've got the 2 columns. They're asking for, on this one, it overwrote the column title. It says it actually wants the lateral area of the pyramid. So that's good. Let's try the lateral area of the pyramid. Formula for that is 1/2 slant height times perimeter of the base. Okay, we don't have the slant height. If you look at what we have the regular height because that drops from the top straight down perpendicular to the center of the base. So I know that's my regular height of the pyramid. So we're going to have to draw a triangle. And so I'm going to imagine the slant height coming down the side of this triangle perpendicular to the base of that side. That's my slant height. And I'm going to look at the segment that would connect that to make that a right triangle there. Okay, so that segment is going to be, it thought I was doing a shape, that's an L. That segment is going to be half of this side. It's going to be half of this side. So if that side is 12, that little segment will be half of that. That will be 6. So let's draw that triangle separately so that we can look at that. So we have the slant height coming down, the regular height, and I'm going to do this in color for you instead. Okay, so we have the slant height coming down on the diagonal. We have the regular height dropping down perpendicular to the center of the base. And then we have that segment from the center over to the base of the slant height. Okay, so we're looking for the slant height. That's what we don't know. That's our L. I do know that the regular height is 9.1. And I do know that half of that side that makes that distance from the center, it's that half of 12, so it's only half of that, we said would be 6. Okay, so if we know 2 sides of a right triangle, we can find the third side with Pythagorean theorem. And so that's going to look like 6 squared plus 9.1 squared equals L squared. Now, how did I know that L went by itself in Pythagorean theorem? Because it's the hypotenuse across from the right angle. So it always goes by itself. It's great when we're looking for the hypotenuse because all we have to do is undo the square with the square root. And so the square root undoes the square. That picks up the plus or minus option. But for geometry, we only want the positive options. So we'll put that in our calculator, square root of 6 squared plus 9.1 squared. And we get that the length, that the slant height rather. So the slant height is approximately, sorry, the shape recognizer wants to call that. I'll just do it as a kind of a diagonal L. Maybe it'll do it better like that. Slant height equals approximately 10.9. Okay, now we need the perimeter of the base as well. Both of the sides on the base here I see are both 12. And so if those 2 are 12, then the other 2 are 12. Okay, so that's my perimeter of the base then. Perimeter of the base is just going to be 4 times 12, or you could say 12 plus 12 plus 12 plus 12. Okay, so 4 times 12 is going to be 48 for the perimeter of the base, and now we're ready to find that lateral area. It's 1/2 or 0.5. My slant height we said was 10.9, and we just found the perimeter of the base to be 48. So I'm going to put that in my calculator. I'll get that the lateral area is approximately 261.6, and that's going to be centimeters cubed or centimeters squared or square centimeters because it's area. We were in the volume column, so it almost got me for a second, but they changed this one, just wants the area. Okay, so that's our lateral area. What else do they want? They want the total surface area, so let's go find that. The total surface area, I'll change colors, is going to be the lateral area, that 1/2 slant height times perimeter of the base plus the area of the base, okay? So the lateral is the sides. So if we're doing total surface area, we need all the sides, plus we need the area of the base on bottom. Now, I know some of you will just pull that lateral area we just found and add the area of the base to it. I'm going to go ahead and use the whole formula. Half of the slant height we solved for was 10.9. The perimeter of the base we said was 48 plus the area of the base we haven't found yet. So we need to do that real quickly. So if I come find the area of the base is just 12 times 12. It's just a square, and so it's just 12 times 12, the length times width of the base. And so that's going to be approximately, the area of the base will be exactly, actually, 144. All right. So now we're ready to come plug that into our formula for surface area. So that's plus 144. And that'll give me a surface area that's approximately 405.6 centimeters squared because it's area. Okay, let's take a look at our next shape. So that was another practice with pyramids. Let's go ahead and take a look at a cone. Remember, cones are very similar to pyramids. Their volume will still be 1/3 area of the base times height because it still comes to that point. But let's see what these look like. Okay, so for this one, the volume we said was 1/3 area of the base times height. Now, the area of the base is, they give it to you specifically, since this formula is just for cones. The area of the base is pi r squared, so it says 1/3 pi r squared times height, but that is the area of the base. All right, so that's just going to be 1/3 times pi. We actually know the radius. They gave it to us. It's 9. And we're in luck. They gave us the height of the cone as well, so that's times 14. So I can go straight to my calculator, and I'll get that our volume is approximately 1,187.5 cubic inches, or inches cubed, for that volume. Okay, so that was nice and easy. We love a cone. Then they want the surface area of the cone. Okay, for the surface area of the cone, its formula is pi r squared, that's the area of the base, plus pi r L, where L is the slant height of the cone. Now, I definitely don't have the slant height of the cone. That would come from the point down diagonal to the side. In fact, I should draw that. I'm going to undo that. I should draw that slant height in so that it's coming down. I thought that would undo, but apparently it won't. We'll erase it. So that it comes down right to the edge of that to make that right triangle that we're going to need to solve to get that slant height. Okay, so let me draw that, let me highlight this and then draw that triangle separately. Okay, so the regular height goes down perpendicular to the center of the base. So that's the regular height, and that's the 14. I'm going to rewrite it there. It's the 14, and that's the regular height. Okay, and then that distance from the center to the edge of the circle, that's just the radius of the circle. We already found that that was 9. Okay. And then the slant height is going to be the one that comes here on the diagonal. So let's go ahead and draw that triangle separately. So we've got the regular height coming straight down. We've got the slant height coming down the edge of the cone. And then we have the radius coming from the center of the circle out to the edge. Okay. So that radius is 9. The regular height we know is 14. And we know that that comes perpendicular to the middle. And so now we're solving for the slant height. Okay, so if we know two sides of a right triangle, we can find the third side with Pythagorean theorem. The slant height is the hypotenuse because it's across from the right angle. So we're just doing 9 squared try again. Okay, so we're doing 9 squared plus 14 squared equals the slant height squared. We're going to undo that square with a square root. Luckily, we're looking for the slant height, so we'll just have to do all of that under the radical. Square root undoes the square, and we get that our slant height is approximately, I'm going to write it over here. Slant height is approximately 16.6 is what I got. 16.6. So the slant height is 16.6. I'm going to leave it here. We've got a lot going on in that picture, but that's my slant height, 16.6. Okay, now we're coming back and we're ready to roll with our formula for surface area. It's going to be pi times our radius, which is 9 squared, plus pi times our radius, which is 9, times our slant height, which we just said was 16.6. Okay, I'm going to put that in my calculator, and I'm going to get that my surface area is approximately 723.8 inches squared, or square inches. Beautiful. Now we're on spheres. I love spheres because, again, those are one of our really fast shapes because there's just not that much that they can do to make it harder. They did all that they can. If we take a look at this problem, they gave us the diameter. I know that's the diameter because it goes all the way across the circle, which means my radius from the center out will be half of that. So my radius will be 11, and that's all we'll need to work with the sphere. The volume of a sphere is just 4/3 pi r cubed. So that's 4/3 pi. Our radius we just said was 11 cubed. If I put that in my calculator, I'll get 5,575.3 millimeters cubed. Cubed because it's volume, cubic units. Okay, what else do they want here? Now they want the surface area of the sphere. Okay, so that's like how much leather you would need to make a basketball, something like that. Okay, let's grab another color here. We'll change to this. So the surface area, formula for surface area of a sphere is 4 pi r squared. So that's going to be 4 times pi. We said our radius was 11 squared. Okay, and so if we put that in our calculator, we'll get that the total surface area is 1,520.5 millimeters squared because it's area, so it's square units. Okay, it's looking great. We've got one more regular shape. Let's move our paper up so we can see that. And this is a hemisphere. Now remember, no hemisphere formulas on your folder, on your formula chart, but you do have the formulas for a sphere, and a hemisphere is just half of a sphere. Notice it says this one is uncovered. So if we want the volume of that, the volume of the hemisphere is just going to be half the volume of the sphere, which is 4/3 pi r cubed. Okay, they gave us the radius, so that's excellent. No work at all to do there. So it's just 1/2, and you can put 0.5 if you want, or if you're getting comfortable with the decimals, you can keep using the decimals. 1/2 times 4/3 times pi. Our radius is 6.5 cubed. If I put that in the calculator, I get a volume of 575.2 centimeters cubed. Okay, let's try our next one. Now they want the total surface area of that hemisphere. Now the hemisphere is only half of the sphere and it's uncovered. So all we need to do here is do half of the surface area of a sphere because it doesn't have an extra top, okay? So it's uncovered. So it's just half the surface area of a sphere. So that's just half of 4 times pi r squared. Okay, so that's just going to be half of 4 times pi. Our radius is 6.5 squared. If I put that in my calculator, I get 265.5 centimeters squared for my surface area. I'm just going to double check my formula real quickly. Okay, looks good. So now we're ready to go ahead and move on to our composite. Okay, we've got a couple of composites to do here. The first one is a snow cone. Okay, so we've looked at the snow cones before. So that's where we have a cone with a hemisphere on top. Okay, and we want the surface area. Well, that's only going to need, my plan is going to be to do the lateral area of the cone plus half the surface area of the sphere. That's my plan. Okay, the lateral area gives me just the sides of the cone, the sides that you can touch, because we can't touch the base of the cone because the hemisphere is on top of it. Okay, so it's not on the surface anymore. So we can only touch the sides of the cone, that's the lateral area. And then we can only touch the surface area of that sphere, and because it's not a whole sphere, it's just a half a sphere, it's only half of the surface area of the sphere. So let's go find those formulas. Lateral area of a cone is going to be pi times the radius times the slant height, and we're in luck, they did give us the slant height on the diagonal there, so that's nice. Okay, plus half the surface area of a sphere is 4 times pi times radius squared. Now, we don't have the radius, but we can find it super fast. We have the diameter. They gave us the diameter, and I know it's the diameter because it's all the way across. That means my radius is just half of that, so my radius will be 7. Okay, so we'll write that there and make sure we use the radius and not the diameter. I'll write this a little closer to your radius is 7. Okay, let's plug in and use it. That means it's going to be pi times our radius of 7 times our slant height of 15 plus half or 0.5 of 4 times pi times our radius of 7 squared. Put that all in your calculator and we'll get the surface area of the snow cone is about 637.7 square feet. I don't know where that random green dot came from, so don't let it confuse you. There we go. All right, so the last one we have on this page is, it says we've got a silo, and that's what grain silos look like. They're usually tall cylinders with a hemisphere dome on top. It's built by taking the lid off the top of a cylinder and capping it with an uncovered hemisphere. That's right, because where the hemisphere sits on, there's not a lid underneath that, okay? So it's just the hemisphere on top. So how much material would it be needed to build the silo? Okay, so my plan there is going to be there's different ways you can do this. I'm going to do the surface area of the cylinder. This time I'm going to do it a different way than we did it in class last time, just to show more than one way to do it. So I'm going to do the surface area of the cylinder minus the one base, the one circle that's covered by the hemisphere that goes on top. Plus the hemisphere on top is half the surface area of the sphere. So let's try it that way. Does that make sense? So we've got the whole surface area of the cylinder less or minus the circle or the one base of it that's covered up by the hemisphere, which is half of the sphere. Let's go find those formulas. Okay, so surface area of a cylinder is 2 pi r squared plus 2 pi r h. Now let's look at that for just a second. The 2 pi r squared are the two bases, and the 2 pi r h are the sides of the cylinder. Now, if we're subtracting the circle, one way that we can show subtracting the circle is to take off the second base. Okay, so we had the surface area of the cylinder, and then we just did minus the base. We took off that base by taking off the second one. Okay, then we're going to add half the surface area of the sphere. Surface area of a sphere is 4 pi r squared. Okay, so we're ready to go. So that's going to be pi r squared. Remember, it's not 2 of them because one of the bases is covered up, plus 2. Oh, I'm supposed to be putting my numbers in now. Let's go try that again. Okay, so pi times, the diameter is what they gave us. 10 is the diameter, but that means my radius is half of that. My radius is 5. This is the height of the cylinder. So there we go. All right, so my radius is 5 squared plus 2 pi. The radius is still 5. The height we said was 6 plus 1/2. 4 times pi times my radius is 5 squared. Okay, if I put that all in my calculator, I'll get that it's approximately 424.1 meters squared. And that is my surface area. Surface area. All All right, I hope this was helpful. If you need help on the third page, we're going to do that on a separate video. So just come check it out if you need help.